page 784, lesson 11.6. Okay, so I'm going to try the ratio test here again. And so we're going to do the limit. I'm going to ignore the limit to start with. And I'm going to put my a sub n plus 1 first. So this will turn into n plus 1 to the 100th. And then this is 100 to the n plus 1. And then this is n plus 1 factorial. And times by the reciprocal of a sub n because I'm dividing by it. And you should be able to get something to cancel here. So what can you get to cancel here? How can I rewrite this piece? The 100, so the 100 dividends will end up canceling over here. And then this one I can rewrite as what? Now this one here is your first term, and then you go down one, so it's n plus 1 times n factorial. So that's what I'm going to write over here. And I'm going to keep the absolute values. I don't know that I need them, but it's not really what I'm doing at the moment. I'm just trying to get stuff to cancel. So I'm writing all the numerator stuff up here, all the denominator stuff, because if you don't write it, you don't get to cancel it. And then the AP reader doesn't see it, so. And a lot of times these are on multiple choice, so if you want to, write stuff like that, just be careful you don't mess something up there. Okay, so I can cancel my 100 to the n. I can cancel my n factorial. Is there anything else? Yeah, we can cancel one of these, right? So that's going to make this to the 99th. Okay. And then we're going to take this, and we're going to take the limit. Now, do I need absolute values around it? I shouldn't, right? Because everything there would be positive. So I'm okay getting rid of those absolute values here. So I've got the limit as we're going to infinity. And now this here isn't going to be written super mathematically when I get to my next step, but I've got 100 times n plus 1 to the 99th. And then in the denominator, I've got 100th. So isn't the numerator like 100 times, and think about multiplying this out 99 times. Okay, you're going to end up with a crazy amount of terms there, like you don't want to do that much FOILing. But what's the very first term going to be? N to the 99th, and then we're going to have something n to the 98th and something n to the 97th. You're going to have all of those pieces. This is really like the dominant piece. So that's the piece that's going to kind of take over the numerator. And the denominator is n to the 100th, right? So if we let n go to infinity, what would I divide everything by? N to the 100th. So the denominator is just going to turn into 1. And the numerator, if I divide everything by n to the 100th, what's going to happen to all of those pieces? And so everything's going to end up going to 0. So we got 0 over 1 here. Does that make sense? Like writing this out exactly right, I don't know how you would do that. So I'm just going to have that be some thought process there. And I would probably, even on the AP test, cross that off so they don't read that. Okay, you might want to write it down for yourself to help you out. And again, this is probably multiple choice, so it's not a big deal if you leave it there. So this we concluded is equal to 0, right? Which is less than 1, which tells you what? Convergent. And is this the same directions as before? So is it absolutely convergent? Yes, so we're going to say absolutely convergent because we did it with absolute values. which means it's also convergent. That's not one of the questions here. And then conditionally convergent. Do you guys remember what conditionally convergent means? No. I think I've got these notes up here. So conditionally convergent, it can't be both of those, okay? It's absolutely convergent if you throw absolute values and it converges. It's conditionally convergent if it converges by a different test, but it's not absolutely convergent. So it can't be both of these. Okay, it's either, well, it's not necessarily either of those, but if it's absolutely convergent, it can't be conditionally convergent. So make sure you just answer the question that was asked there. Determine whether it's absolutely, conditionally, or divergent. So it's absolutely convergent. And by what test? No, what's that test called? A ratio test. Okay, we're going to use that ratio test a lot, so. Okay, so I'm going to take a look at 29. If you're not there yet, you might want to jump to here. If you don't really feel like jumping to here, just ask me to send you the recording. Send me an email or something. I can forward you the recording. But 29 here is a little bit more of a challenge. We're still going to try doing the ratio test on it. So we're still going to do our a sub n plus 1 and multiply by the reciprocal of a sub n. So let's start with that. So our a sub n plus 1 is still going to be our 2 times 4 times 6 times dot 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 times, and what's our very last term going to be? So it's really going to be 2 times n plus 1, isn't it? Which is 2n plus 2. What's the term before that going to be? And this is where this problem makes more sense if you have the term before it. So what's happening to these terms as we go up? You're adding 2. So to go backwards, we would get what then here? 2n, because you'd subtract 2. Okay, and that'll make this problem make a lot more sense. So we're going to keep that 2n there.
Where'd you get 2n plus 1?
This here? This is my a sub n plus 1. Okay, so I'm finding what my a sub n plus 1 is, and then I'm going to divide by a sub n or multiply by the reciprocal of a sub n. Does that make sense? We're just starting that ratio test. Yep. So in the denominator for a sub n plus 1, I've got n plus 1 factorial. And right at this moment, if you want to write that as n plus 1 times n factorial, you can do that as you get better at these and quicker at these. When we get to 11.8, you'll probably be doing that a lot. So any questions on a sub n plus 1? Does that make sense? Does everyone see where these pieces came from? Because that's kind of the key to the problem here. So we plug n plus 1 in for n, distribute the 2 through 2n plus 2. So that's the very last term. And they're going up by 2, so you go down by 2 to get this term here. Okay, then we're going to multiply by the reciprocal of what's in here. And I'm going to throw my absolute values around it, just because that's how the test is written. And what do you notice is going to cancel? All of this, all the way to 2n, right? So all of this ends up canceling. And then this we can change into, we said, n plus 1 times n factorial, right? So then the n factorials cancel each other out. And do I need absolute values anymore? I shouldn't, right? So now I'm going to go ahead and take my limit. And I've got 2n plus 2 over n plus 1. Divide everything by n, we end up with a limit of to, which is greater than 1, which tells us what? Divergent. Okay, so we've got divergent here. And it's one of those three things, so we have already got our answer there. It's not absolutely convergent. It's not conditionally convergent, because if it's conditionally convergent, it's got to converge, and the absolute value doesn't. It's just divergent. So, yep. So I'm going to find what a sub n plus 1 is up here, because I feel like it's going to be messy and I can clean it up. So this is 10 to the n plus 1, and then the denominator would be n plus 1 or n plus 2 in here. And then this is 4 to the 2 times n plus 1 plus 1. So the numerator you could turn into 10 to the n times 10. You figure out what you did wrong? Okay. And then we got our n plus 2. Yeah, I just want to keep going. It's more fun for me. So we got 4 to the 2n plus 3. So really my a sub n plus 1 is 10 times 10 to the n on top. And then we've got n plus 2. And this is 4 to the 2n, which I'm guessing I want to keep that way because of my other one. And then this is 4 cubed. And then I'm going to multiply by the reciprocal of that. So if you're good to go, you can keep moving on it. And I'm just rewriting 4 to the 2n plus 1 is 4 to the 2n times 4. So I think this is what I end up with, and I'm going to do the limit of it. And the 10/16ths could reduce to like 5/8, and you could pull it out front if you want to. Just make sure you don't forget about it. Because the limit here goes to 1, but then you have that 5/8. So I'm getting that it's convergent, which in this case it's asking if it's absolutely convergent, and it is. So it's both, obviously. That's what I'm getting. I'm not positive it's right because I haven't checked the answer, but looks good.